Hello everyone, my name is Alvaro, and in this video I will be solving another problem from the Leetcode 75 problem list on Blind. And today I will be solving the problem 226, invert binary tree. So once again, we're dealing with binary trees. So let's read the problem statement, check the code, and see what this problem is about. So let's start. Given the root of a binary tree, invert the tree and return its root. Example 1, we have this tree that has a 4, 2, 1, 3, and then a 7, a 6, and a 9. And then what we do is we switch the left and the right tree, and within each one we also flip them. Okay? Here as well, a more simplistic example. So we just flip them, and if the input is none, then we return an empty tree. Perfect. All right. And as usual, our tree node structure has 3 variables. One is value, one is left, representing the left child, and one is right, representing the right child. So, if we start to make sense of this problem, we can establish a recursive relationship as well. I think example 3 gives us a very nice base case right here, in which if the current root is none, then we will obviously return none. So we can start with that. And as it is usual with recursive problems, if you're not familiar with recursion, I encourage you to just keep doing these problems and eventually it will click. I will do my best to explain the recursive relationships, so I hope these help, but if you feel like you need to practice more, then be my guest and just keep doing more problems. More practice is never going to hurt. So, example 2, I think, does a pretty good job explaining the recursive relationship. The main idea here is that we are going to bubble down the tree until we eventually hit the bottom level for whatever node we are at. So once we hit the bottom level, we're going to reach a point where the child either has 1 or 2 children that are none, meaning that are null. So once we hit that, we are going to return none. So what we have to keep track in some way of one of the children, and the way we do that is by creating a variable. We can call it left, for example, and then call the invert tree method on root.left. So left is equal to invert tree root.left. And then similarly, right is equal to that. Right is equal to self.invert tree root.right. Now, let's assume that these flip the tree, then it's fairly evident that at that point, all that we need to do is we just need to assign left to root.right and right to root.left. So we can say root.left is equal to right, root.right is equal to left. And obviously, like I've done sometimes, not all of these lines are necessary. For instance, what we can say is left is equal to this, and then we can say that root.left is equal to all this, and then we just say root.right is equal to left. But I like to do it this way so that it's easier for you all to understand. So once we have this, we have flipped the left and the right children, and all that's left to do is to return the root. And after that, let's run the example, for example, on example 2. Let's check it manually. So we start at node 2. Root is not none, so we don't enter this if statement. And then we say that left is equal to, and then we call it on the left child. So we have a 1 here. And within the 1, we call it again on the left and the right child. We can see that for this node, variables left and right are equal to none because the children of this node are none. So left is equal to none, right is equal to none. So root.left is equal to none, root.right is equal to none, and then we return the root. So we have a 1 here. So for node 2, the variable left is equal to this node right here, node 1. Now we call right. So we go on line 16, and now we call it on node 3. And now we enter node 3. Similarly to 1, the root is not none, and both left and right for this node are going to be none. So none and none, and after that we return the root. So now we have that left is equal to this node right here, and right is equal to this node right here. So then we say root.left is equal to right. So now the left child of this node right here will be this one, and root.right is going to be equal to left, which is this node right here. So the right child is now 1, and this successfully gives us the output that we want. If you want to take some time and check this example manually by yourself, try example 1, but it should also give you the correct output, as we can see now when we submit the code. And like I said multiple times, there are some variances due to connection and stuff like that, but in an interview, this is an accepted solution and it's the efficient one. So, what is the runtime of this problem? The runtime of this problem, as you can see, it's O of n, because we're going to visit every single node in the tree. Since we visit every single node in the tree, then obviously, and n is the size of the tree, then the runtime is O of n. And what is the space-time complexity? Well, once again, since we're doing a recursive solution, the worst case scenario is that we are going to have a tree that is completely skewed, which means that, like I've said in other tree problems, every single node has one child. So we just go and go and go, and then in this case, for example, if we have 1, 2, 3, 4, if we have 7 nodes, then the tree will be of height 7. So in the worst case scenario, the space-time complexity is O of n, where n is the height of the tree. And the expected space-time complexity is O of the height of the tree. And when the tree is fully balanced, like this one, then the height is O of log base 2 of n. All right. Thank you very much for watching the video once again. I hope that it was helpful. Again, there probably is an iterative solution, but generally speaking, in an interview, they will not ask you to implement this iteratively, mostly because this problem right here is considered an easy one. So if you get this problem, I expect that you would get it on a company that's recruiting for internship positions probably. But nonetheless, it's a good problem to know because, it helps you understand a little bit about recursion. So yeah, once again, like I said before, thank you very much for watching the video. I hope that you find all these videos helpful, and see you on the next one. Bye-bye.